Welcome back to another fun lesson. Today we are going to work on sketching a cubic graph. Just try and follow all the steps and try and remember them. Unfortunately, that is study work to remember how to get to your answer. I hope you enjoy it. Steps to sketching a cubic function. So the first thing that you do is determine the x value of or values of the stationary point or points by letting the derivative of f equals 0. So that is very important to remember. Determine the y value of the stationary point by substituting the x value back into fx, the original formula, not into fx. The next step is determine the shape of the graph. If a is bigger than 0, the shape of your graph will look like that. Note that in this case, the stationary point with a lower x value will be a local maximum, and the stationary point with a larger x value will be a local minimum. So that will be your maximum and that will be your minimum. The same with a smaller than 0, the shape of the graph is this way around. You'll see it's just the reflection. Note that in this case, the stationary point with a lower x value will be the lower minimum, and the stationary point with a larger x value will be the local maximum. Steps to sketching a cubic function. If we go to the next one, determine the x and the y intercepts by letting y equals 0 and x equals 0 respectively. If asked to determine the x value at the point of inflection by letting fx equals 0, you'll see we'll derive it twice. Determine the y value of the point of inflection by substituting the x value of the point of inflection again into fx and not in the derivatives of fx. The graph of a polynomial function is continuous. It has no breaks, holes, or gaps. It only has a smooth, rounded turns. An example of using synthetic division. This is just a quick way of explaining this because you are going to use it in the next one to sketch a graph. If they say divide 2x to the power of 3 plus 11x squared plus 18x plus 9 by x plus 3 and factorize completely. So this, you can actually see x is negative 3. So what you do is you draw your little block and you write in 2, 11, 18, and your 9. Remember, x is minus 3. Easiest ways to explain it, you bring the 2 down, and every time you go around the corner, you times. That will be minus 3 times 2 equals minus 6. First that you do, you're going to minus 11 minus 6 gives us 5. We're going to times again. Minus 3 times 5 equals negative 15. 18 minus 15 equals 3. We're going to times again. So that will be minus 3 times 3 equals negative 9. And 9 minus 9 equals 0. So your answer will be, if you divide x plus 3 into 2x to the power of 3 plus 11x squared plus 18x plus 9 equals 2x squared plus 5x plus 3. Please remember how to use this. I'm not going to show it again in the examples, but just remember that's how we do that. So let's start. Sketch the graph of fx equals minus x to the power of 3 plus 7x squared minus 15x plus 9, showing all stationary points and intercepts with the axis. So the first step that we do, Determine the x value of the stationary point for fx or f derivative. So we immediately go over and we factorize. So that will be minus 3x to the power of 2 plus 14x minus 15. Remember that falls away and 9 does not feature. Now for your stationary point, you make the derivative of x equals to 0. So you will have minus 3x squared plus 14x minus 15 equals 0, and you factorize. So your answer will be x equals 5 over 3 or x equals 3. Step 2. Substitute the x values into the equation, remember, of fx to solve for the y values. So the 5 over 3, we'll fill it in and you can work it out on your calculator. You'll get an answer minus 32 over 27. So the stationary points are where x equals 5 over 3, your y value will be minus 32 over 37. And we can see here that 3 and 0 is also an x-intercept. So sketching the graph, the next step is test for the shape, because you need to know what it's going to look like. A is smaller than 0. I'm just going to go back to this slide. Remember, you look at the coefficient of the biggest x value. So x to the power of 3 is the biggest one, and it's a negative. So that's why it will be smaller than 0. And your shape will look like that. So your local minimum will be at that point, and your local maximum is at 3 and 0. The next step is determine the intercepts using the factor theorem and the synthetic division. Remember that what I've showed you a few slides before? So we will start with your x-intercept, let y equal 0, and you fill it in. 0 equals minus x to the power of 3 plus 7x squared minus 15x plus 9. And you just divide this side with minus 1 in order to get your answer. Your y-intercept, let x equal 0. That's easy. Your answer will just be 9. Now remember, we say f3 equals 0. In step 2, it was shown that 3, 0 is an intercept. So we know that x minus 3 is a factor. So you're going to use your synthetic division and we'll get our answer. And you factorize further to get your two brackets. So you will have x minus 3, and x minus 1. So x equals 3 or x equals 1. So your x-intercept will be at 1, 0 and 3, 0. So the easiest way is you can just go and sketch it. I just did it beforehand. But there you will see you will have your y-intercept and your two x-intercept, and then we've already done our turning point is 5 over 3 over minus 32 over 7. I hope you understand that and that it's easy, or that you understand it. Sorry, that must be 27. So it's minus 32 over 27. So you take all your information that you have and you can go and plot it. If we look at sketching points of inflection, so we basically do more or less the same steps in order to get that. So you need to sketch the graph of gx equals x minus 1 to the power of 3 minus 1, showing all the stationary points and the intercepts with the axis. So it's very similar to the previous one, but we will work through all the steps. So the first one is determine the x value of the stationary points. First, you need to factorize to get your standard form before you can differentiate. So you can't really differentiate from that point on. So you need to factorize, and in the end, your answer will be x to the power of 3 minus 3x squared plus 3x minus 2. Just do it step by step in order to get to your answer. So step 1 continues now. Now we can work with what we have. And remember, for a stationary point, your derivative of a gx must be equal to 0. So from there, you first go and get gx. Remember, so it's again 3x squared minus 6x plus 3. So it's the same as that one. So remember, from there you go to the next step. And you say equal to 0. Divide both sides by a minus 3. That's actually a plus 3, sorry, a plus 3. And then you can factorize again in order to get your x. So there's only one stationary point, and this is also the point of inflection. Sketching points. So step 2, substitute the x value into the equation to solve. Remember, you go to the original equation. So you fill in your 1. So 1 minus 1 is 0. 0 to the power of 3 stays 0 minus 1. So that will be your value. The point of inflection is 1 and minus 1, x and y value. Test for the shape. Because a is bigger than 0, your shape will look like that. Step 4, determine the intercepts. Intercepts is when you may let y and x be 0. So for the x-intercept, let y be 0. And you cube root both sides. So basically cube root. And your answer will then be x minus 1 equals x. If you take it over, x becomes 2. So your x-intercept equals 2 and 0. Your y-intercept, let x be 0. You fill your 0 in everywhere there's an x. And your answer is minus 2. And I've just also sketched it. You know what your form looks like, so it's easy. So x2 minus, let me do that. It's just easier. That's your point there. 0 and minus 2, that is your point there. And your inflection is 1 and minus 1. I hope it makes sense. Just get all the information first before you draw your picture. It just makes it easier. So stationary point and one other point. If they give you that, you need to sketch the graph. We'll have a look. So in this case, you will be given the coordinates of a stationary point and one other point on the curve, usually the y-intercept. You will then be expected to solve for two unknown variables in the equation using simultaneous equations. If you can't remember simultaneous equations, please go back to some of the previous slides where it was explained in order to be able to do this. The graph shown below has the equation y equals x3 plus bx plus cx plus d. It has a stationary point a2 and minus 32 and passes through the origin determine the values of B, C, and D. Hence, write down the equation in the form. Let me just quickly. Yeah, ek moet net gou hom kry. Hier is hy.